Okay, so we're going to look at the first Intro to Transformations lesson. So transformations is a general math term that we use for moving and stretching functions. Okay, you've already seen this a little bit in grade 10, and we'll talk about that a little bit too. But there's three main functions that we use to learn about transformations. So the three functions that you're going to see is the function f of x is x squared. That's the quadratic. We've already seen that in grade 10. There's f of x is square root x. That's called the radical. And there's f of x is 1 over x. That's called a reciprocal, because 1 over something is a reciprocal. Okay? So these are called the parent functions or the base functions of their families. Okay? So before we learn about transformations, first we have to see what these base functions look like. Okay? So the quadratic is what we start with. So f of x is x squared. Okay? And some key points for the quadratic. We know that 0, 0 is in the middle. And then we're going to look a little bit to the left and a little bit to the right. So left means x is -1, -2, -3. And to the right is 1, 2, 3. And now we know that we can find the y values by saying f at -3 is -3 squared. So that's 9. And then for the second one, we can say f at -2 is -2 squared. So I'm replacing x with -2. -2 squared is 4. Then we can say f at -1 is -1 squared, which is 1. This one came from f at 0, which is 0 squared, which is 0. And then we can do it all again with the positives. So f at 1 is 1 squared, which is still 1. F at 2 is 2 squared, which is 4. And f at 3, which is 3 squared, and that's 9. Right? So let's plot these points. I know I have my vertex here at 0, 0. And then we just have to remember these steps. So we have 1, 1, 1 to the right and to the left. And then for the 2, so as we go over 2, we go up 4, and same on the left. And then 3 squared was 9. So as we go over 3, we go up 9. Right? So that gives us our key points for a quadratic base function. Okay? So that's the function x squared. Now let's look at two new ones. So the radical, which is f of x, is the square root of x. Okay, so first we can go, let's start with -1. Well, the square root of -1, we put that into our calculator and there's an error. We can't do it. Okay, so we can't take square roots of negative numbers because square root means that two numbers multiply to make that negative number, and I can't have two numbers that are the same multiply to make -1. Like -1 times -1 is +1, and +1 times +1 is also +1, so it doesn't work. So we can start with 0, and then f at 0 is the square root of 0, which is 0. So I have a point at 0, 0. Then I can look at the point when x is 1. Well, f at 1 is the square root of 1, which is 1. So there's a point at 1, 1. Now if I try 2, when I put the square root of 2 in my calculator, it gives me like 1.41 something something. Okay? I don't want to use that because it's not a nice number. So I'm actually going to take that out of my table of values. So then if we try 3, the square root of 3 is like 1.6 something something. And so I'm not going to use that either. Now the square root of 4, when I put that into my calculator, I get the square root of 4, and that's 2 because 2 times 2 is 4. So that means when x is 4, y is going to be 2. There's another nice point. And then the next nice one is I can try 5, 6, 7, 8, but 9 is the next square number. And the square root of that is 3, because f at 9 is the root of 9, and that's 3. So 9, 3 is the next nice point. Okay, so that is the graph of my radical function, which is f of x or root x. So if we remember what the actual function does, then we can build this table of values every time if we need to. Okay? All right, let's look at this rational function. So this is the function f of x is 1 over x. Okay? So let's try again -3, for example. Well, f at -3 is 1 over -3, which is -1/3. So I have a point at -3, -1/3. Okay? So now let's look at -2. Well, I know that that's going to be -1/2, right? Well, that means -2, -1/2 is a point. Then when I look at -1, well, that's -1 over 1, which is just -1. So -1, -1 is a point. Okay? Now, when I try to look at 0, f at 0 is 1 over 0. Well, I'm not actually allowed to divide anything by 0. So this doesn't work. Okay? So I'm actually going to erase that. And if it doesn't work at 0, I'm kind of curious to know what happens at -1/2. Okay? Well, f at -1/2 means that it's 1 over -1/2. Well, 1 over -1/2, you can do this on your calculator, but it's the reciprocal, so it's positive. Sorry, it's -2 over 1, which is -2. So at -1/2, I'm down to -2. Okay? I'm also going to try negative. I want to see what happens if I do -1 over 3. Well, f at -1 over 3. If I plug that into my calculator, it's -3 over 1. So that means -1/3, I'm down to -3. So actually what's happening here is to the left, if I make x bigger and bigger, the function is getting close to 0, right? It's getting closer and closer to 0. And as I make the denominator closer to 0, the function's actually becoming bigger and bigger negative numbers, like -1. So you can see here, -1, -2, next one's -3, right? So we get something called an asymptote. So there's a line here that's an imaginary line that this function gets closer and closer to but never touches. And it's the same here. Okay, so these are these asymptotes. So a vertical asymptote is this one that goes up and down, and a horizontal asymptote is this one that goes sideways. So this one, its equation is x equals 0, because everything along that line is x equals 0. And this function can never have an x value of 0, because I can never have 0 in my denominator here. Right? I can never do 1 divided by 0. Right? And this other one is y equals 0, because my y values are never going to be 0. It does, if I have 1 in the numerator and I divide 1 by something, there's always going to be a little bit. Even if x is 1,000,000, I'm going to have 0.0000001. It's never going to be 0 exactly. Okay? So that's what's happening to the left here on the negative side. Okay? So let's take a look at what happens when I cross over to the positive side. Well, you can see that exactly the same values are going to happen. So here, let me just pull a line here. That's kind of like my asymptote. And then if I go into positive 1/3, well, it's going to be 3, right? It's the same value, but positive. So as I go to positive 1/3, my y value is 3. And if I go positive 1/2, my y value is 2. So now I'm at 2. And if I go to positive 1, my y value is 1. So everything's mirroring. And if I go to positive 2, my y value is 1/2. And if I go to positive 3, my y value is 1/3. Right? So there's this part of the function that looks the same, it's just on the positive quadrant. Okay? So that's our last base function. Okay? So we're going to spend a few units. We're going to do a lesson for each one of these functions. So how we move a quadratic, how we move a radical, how we move a reciprocal. Today, we want to look at just the general transformation of functions. So some things that we can do to transform functions is if we add a value to our function, that's called a vertical translation. So that means that it moves the graph up or down. Okay? If I multiply my function by a value, that's called a vertical stretch or a compression. It's a stretch if the a value is bigger than 1, and it's a compression if the a value is less than -1. Less than 1. And if the a value is negative, we get something called a vertical reflection. Okay, so we're going to see a bunch of examples with this. Okay, so there's a vertical stretch, a vertical compression, and a vertical reflection. Okay, and then there's some things that we can do horizontally to the x coordinates. So we can horizontally translate, so shift things right and left. We can do stretches and compressions if we multiply the x values. Okay, and what we're going to see here is that whatever happens to x is always opposite of what looks like is happening. So x minus d, so minus 2, so x minus 2 would be right 2. X plus 2 would be left 2. So same as what we saw in parabolas in grade 10, whatever happens to x is opposite. So same here, 2x would be a compression. A half x would be a stretch. Okay, we'll see more examples of that. And again, if we have a negative k value, then it's called a horizontal reflection. So the order of transformations is important. We have to do stretches, compressions, and reflections first, and then translations. So stretches, compressions, reflections first, that's like multiplying and dividing. And then translations is like adding and subtracting. Okay? So, list of transformations and the order in which they should be done. So let's see what's happening here. So if I get a function by doing negative of another function, well, that negative is like multiplying f of x by -1. So I'm multiplying the whole function by -1, which means it is a vertical because it's happening to the whole function, not just the x, so it's vertical, and it's a reflection. Okay, and we'll see what that looks like in a few minutes. Let's look at this next one. So here there's a 2 multiplying the entire function. So that means it's vertical and in this case, a stretch by a factor of 2. And then there's something multiplying x. So if we're multiplying x by 1/3, then it's a horizontal stretch or compression because it's happening to the x's. And it's a horizontal. In this case, this value is between 0 and 1, right? So if it's between 0 and 1, that means it's a horizontal stretch. So remember, horizontal things are opposite of what they look. So it's between 0 and 1. It feels like it should be making it smaller, or it should be a compression, but it's opposite. So it's a stretch. And it's easy to find what's a stretch by. It's a stretch by the opposite of 1/3. So it's 1 over 1/3. So sometimes it's easy to see that it's just 3, because that's the opposite of 1/3. But if we can't see that it's just 3, we can just pump this into our calculator. And 1 over 1/3 is 3. Okay? And so those are the two things happening. All right, let's look at the next part. So first, multiplying things. Well, there's a 3 multiplying the whole function. So that's a vertical stretch by 3. Okay, that's 1. The next thing is, there's something happening here, the adding and subtracting. Well, there's adding 2 to x. So because it's to x, it's horizontal, right? And because we're adding 2, it's the opposite. So it's 2 to the left. So horizontal translation. Horizontal translation to left. Okay, so with x's, it's opposite. And then out here, I'm subtracting 1 from the whole function. So because it's the whole function, it's vertical. It's a translation because it's adding or subtracting. And when it's vertical, it's exactly what it says. So -1 means down 1. So when it's happening to x's, it's right, left. When it's happening to y's, it's up, down. In this case, it's down 1. Okay, let's look at this next one. So there's a few things. So first, let's deal with this 1/4. Well, the 1/4 is multiplying the whole function. So it's vertical. With the vertical things, it's exactly what it looks like. So because it's a quarter between 0 and 1, it's a compression by a quarter. Okay, let's look at the next multiplying dividing thing. There's a 2 that's multiplying the x. So because it's multiplying the x, it's horizontal. Right? And because it's bigger than 1, it seems like it should be a stretch, but because it's horizontal, it's always opposite. So it's actually a horizontal compression by, and it's 1 over whatever that value is. So in this case, it's 1 over 2. Okay? And the last thing is, there's 1 being subtracted from x. So it's from x, it's horizontal. And because it's being subtracted by 1, it's a translation 1 unit to the right. Okay, so always opposite. -1 should mean left, but it means right. Okay. Let's look at this last one. Okay, so first, there's a negative here. That means that there is a vertical reflection. Okay? Next thing, the function's being multiplied by 5. So the function's being multiplied, that means it's vertical. And multiply by 5 means it's a stretch by 5. Okay? Next thing, there's a negative in with the x inside the function. So that means there's a horizontal reflection. Okay. Next, the x's are being multiplied by a quarter. Multiplied by a quarter, so it's happening to the x's, so it's horizontal. It's multiplied by a small number, so it should be a compression, but because it's to the x's, that's actually opposite. So it's a horizontal stretch by 1 over a quarter, which in your calculator or in your head should be 4. Okay? So we've done all of the reflections, we've done all the stretches, compressions. So now let's look at this. We're adding 2 to x. So that is a horizontal translation. And because we're adding 2 to x, it's 2 to the left. And then there's this plus 7. So that's a vertical translation. 7 units up because it's plus 7. Okay, so that's all the possible things that could happen. Okay. All right. Let's look at some examples. We're actually going to take a function and do something to it. Okay. So we want to list the transformations and we want to use the graph to sketch the new graph. Okay. So this is the graph of f of x. We want to sketch g of x where it's f of x plus 2. Well, there's no multiplying, so there's no stretches, compressions, but there is plus 2. So that means that there's a horizontal, because it's just happening to the x's, translation, because it's adding, 2 to the left, because it's opposite. Okay? Now, we can just take this graph and move it 2 units to the left. So I'm going to take all the key points. I'm going to move them 2 units to the left. And there's my new graph. Okay? Now, that looks very complicated and messy when we just do it like that. So this point is going to go 2 to the left. This point's going to go 2 to the left. This point's going to go 2 to the left. This point's going to go 2 to the left. And now I get this with just the new points. Right? So you see how the red graph moved 2 units to the left. Okay? I'm going to show you a different way that we can get the same graph that I want to get used to. And it's called using the mapping rule. Okay? So the mapping rule means we're going to take the old points. And so the old points were, this was -3, 2. So -3, 2. This point here was -1, -3. This point here was 1, -2. And this point here was 3, -2. Okay? And now we're going to write a mapping statement. So what's happening to the x's? Well, everything is going 2 to the left. So that means that the new values are going to be x minus 2. Right? Because it's 2 to the left. And the y values, nothing's happening vertically, so the y values I'm just going to leave. So there's my mapping statement. And so now I'm just going to move all these points. The new x point is going to be -3 minus 2 is -5. And then the y value 2 is just going to stay 2. The x value of -1 is going to become -1 minus 2, so -3. And the y value is just going to stay the same. The new x, the old x value of 1 is going to be 1 minus 2, that's -1. And the y value is going to stay the same. And then the x value of 3 is going to be 3 minus 2, which is 1. And the y value is going to stay the same. So I'm going to use this purple to plot where these new points are. Negative 5, 2 is negative 5, 2. That's right there. See how we had that point? Negative 3, 3 is right here. Negative 3, 3. Negative 1, negative 2. Negative 1, negative 2. That's that point right there. And then 1, negative 2. 1, negative 2. That's that point. So see how we can get a graph? Like if I don't want to do the whole shifting the graph over point by point, I can just do this mapping statement and I can plot the new points. So negative 5, negative 2, or sorry, negative 5, 2, negative 3, negative 3, negative 1, negative 2, and then 1, negative 2. And so here is the purple graph that matches the red graph. Okay? So that's called a mapping rule. Okay? Where we write what's going to happen to the points. Okay? So we're going to try to use that to now map this one. Okay? So what's happening here is a vertical reflection. Okay? So I'm going to use the old points. Well, the points are the same as in the old graph. So negative 3, 2, negative 1, negative 3, 1, negative 2, 3, negative 2. Okay? All right, so it's a vertical reflection. Vertical means it's happening to the y values, and reflection means we're making them all negative. So the y values are going to now be negative y. Nothing horizontal is happening, so I'm just going to keep that x. So negative 3, negative 2 instead of 2. Negative 1, instead of this negative 3, now it's going to be negative 3, which is positive 3. When x is 1, negative 2, which is positive 2. And when x is 3, negative 2, which is positive 2. So let's plot these points. So negative 3, negative 2, negative 3, negative 2, negative 1, 3, 1, 2, and then 3, 2. All right, let's connect them all. All right, and so you see how everything's just been vertically reflected across the x-axis. Okay? All right. This one, negative 3, 2, negative 1, negative 3, 1, negative 2, 3, negative 2. That's my old. Now what's happening here is there looks like a vertical is just happening to the outside of the function. Translation, 3 units up. So vertical, so x's are going to stay the same, and y is y plus 3 because it's 3 up. So negative 3, 2 plus 3 is 5. Negative 1, negative 3 plus 3 is 0. 1, negative 2 plus 3 is 1. 3, negative 2 plus 3 is 1. Let's plot these new points. Negative 3, 5. See how that's moved up by 3? Negative 1, 0. Moved up by 3. 1, 1. Up by 3. And 3, 1. Up by 3. And so there's my new graph. Okay, now let's do one more. So here, there's a couple of things happening. So first, stretches, compressions. Well, to the x, I'm multiplying by 2. So because it's happening to the x, it's horizontal. Multiplying by 2 means it's a compression. Remember, opposite. By 1 over whatever that number is. So 1 over 2. And then the minus 1 part is happening to the whole function outside of the x. So it's vertical. It's a translation, because that's when we add or subtract. And it's minus 1, so it's down 1. Okay, so let's do our points. Negative 3, 2, negative 1, negative 3, 1, negative 2, 3, negative 2. Now let's write our rule. Well, horizontally, so the x's are being compressed by a half. So it's going to be a half x. And vertical translation, so y is down 1. So take away 1. All right. So negative 3, a half of negative 3 is negative 3 over 2. Or you can think of that as negative 1.5. And then the y value, 2 minus 1, is 1. The x value is a half times negative 1. That's negative a half. And then negative 3 take away 1 is negative 4. 1 times a half is a half. Negative 2 take away 1 is negative 3. 3 times a half is 1.5. Negative 2 take away 1 is negative 3. Let's see what that looks like. So our x value is negative 1.51. So negative 1.51. So this point has been compressed by a half. So it's been brought half closer to the axis. And it's been brought down 1. So halfway as close and down 1. Negative a half, negative 4. So negative a half, negative 4. Again, halfway is close and then down 1. A half, negative 3. Halfway is close and then down 1. And then 1.5, negative 3. Halfway to the axis and then down 1. Okay, so this graph has been compressed by a half and brought down by 1. Okay, so that's how we work with mapping statements. That's how we name translations, reflections, compressions, stretches, and that's how we move graphs.